Good morning, students. I am Arpita Mazumdar, Assistant Professor in Computer Science and Engineering Department of Haldia Institute of Technology. Today's discussion is on referential integrity, which is a very important concept in relational database management system. Here goes the outline of the lecture. First, we will cover up the constraints null, unique, primary key, check, and last we will cover up the whole concept of referential integrity. First, I would like to discuss about the null concept. Null is a value which represents inapplicable or unpredictable or unknown value. Please note this very carefully. For numeric data, null is not 0, and for character, null is not a single space. Even for a string, null is not a series of blank spaces. Null is a value which represents when the data is not present. That means you don't know about the data. At that point of time, it is unknown, or the data is in that position, that value is not applicable, or you cannot predict it. Now let us explain with some attribute value. Say salary. Sal means salary. Salary of an employee. It is an integer data, or it holds some floating point value, whatever, numeric data. So sal, when it is 0 is a value, numeric value. That means he has not got any salary. But if the sal is null, that means salary component is not applicable for that employee. Say the owner of the company. Definitely he is not a salaried person. So in his case, salary field will have null values. This is applicable for commission also. If the commission component is having a 0 value, that means at that point commission he got 0. That means he did not receive any commission. But if the commission value is null, let me rub it. If the commission value is null, that means for that person commission is not applicable, or you at that point of time you may not know the value also. So I think this concept is clear. Now let us check where we can put null values and where we cannot. Say unique ID. In any class, the student entity, we get an unique ID by roll number, which is a unique feature of the student by which you can easily distinguish between among the students. So that roll, this is distinguishing feature. So, and you have heard about the word primary key. That concept I will go on for the next few minutes. So roll cannot have null value. It's not null. Similarly, name in case of say product. For product name, always you give some unique name. So in that case also you will not go for any null value. But in case of say phone number, if you don't know at that point of time, you can apply null value. But you cannot keep just 0, it will have no meaning. You cannot keep it blank, because blank is not null. Okay, so I think this much it is clear. Now let us go to the next is unique. Unique means we will not repeat the value. No redundancy. Every values are different. See, its values are unique. So when an attribute is having unique value, that means for all the values, all the tuples, we know we are learning RDBMS, so each and every tuple, that is T1, T2, that means these are all records. All the records will have some unique values. Say for product name, normally all the product will have different values, unique values, no redundant values for the product name. So we will apply this unique constraint for product name. I think all of you understand the student name you cannot claim that have to be unique, because we see in this class only so many Vishal Kumar are there, so many Sunny Singh are there. So you cannot say that student name will be unique. So you must be clear of the idea where you can put unique constraint, where you cannot. Fine. Very important concept here one is that when you are using the unique constraint, please be aware that you can have null value. Null value is allowed in case of unique constraint, right? That means if any product name is not known to you at that point of time, you have not decided, some product ID you have decided, but say product ID 100, but at that point of time you have not decided, or that is unknown to you, you can put a null value there. Am I clear? Right. So please carefully understand this. Fine. Next is primary key. Primary key, an attribute or a set of attributes. What feature it is having? It must be unique. That means no redundant values must be there, and it must be not null. That means null values are not accepted in case of primary key. Because very clearly we should understand that primary key objective is it should be capable of identifying each tuple uniquely. So if we are able to allow the null value, so definitely too many null values will not be, you will be able to distinguish each and every tuple. So please carefully note that So please note carefully that whenever an attribute is having primary key constraint, it has to be unique and not null. Say for example, employee ID. Employee ID is the primary key of employee table or relation, by which each and every tuple of the employee table can be uniquely identified. No two tuple, that means no two employee, will share the same employee ID. And the same goes for department ID also. No two department have same department ID. For you students, it will be very easy to understand with your data. In the class, each and every student is identified by roll number. No two roll number are same. Roll number, same name you are having. So roll number 1, if it is Sunny Singh, roll number 2, that person can also have another Sunny, but these two are different. So roll number distinguishes between the students, and at any point of time you cannot insert any null value in case of primary key. We know this very well. Okay. Next is check constraint. Checks the condition. Say, if we want to restrict the age of the students, between 18 and 20. During the creation of the relation, we can give this check constraint and write like this, that age is the attribute, data type is number, 2 is the data size, and what checking constraints we are applying, that the age should be entered and it has to be between 18 and 20. So these are all constraints what we want to discuss. I think at this point of time there should be no doubt. Next. Fine. Now the major concept what we are covering up is referential integrity constraint. Okay. I am reading it out, then I will explain with the example. The constraint states that a tuple, you know what is a tuple? Tuple is a record. Because we are learning RDBMS. RDBMS means Relational Database Management System, where we collect data about different entities and it is in a 2D table. And each row, that means table means 2D, rows and columns. So here if you see, this is an employee table. We have entered different data regarding the employee ID, e-name, department number, these are the attributes, and this is T, sorry, wait a second, this is T1, this is T2, means tuple 2, and this is T3. So there are 3 tuples. 3 tuples means each tuple is telling the information, saving the data regarding one employee. So we can see there are 3 employees. Similarly, department, Dept is the table, and where 2 attributes are there, and these are the columns, attributes, and the rows are the tuples or records. So tuple means each record. Fine. Next goes, so what is the constraint saying about? Constraint is about, the constraint states that a tuple in one relation that refers to another relation must refer to an existing tuple in that relation. See, by learning this line, it will not make any sense if we don't understand with an example. So just replace this one relation, first relation, by employee. Say this relation name is employee, and which refers to another relation. This relation is Dept. So what is happening? Let us go by the line in a different way by replacing these values. The constraint states that a tuple in employee table that refers to department table must refer to an existing tuple in that relation. That means in department relation. Let us check. What is happening? In this employee table, first you say students, these 2 tables, which is the first table you have to create? That means which is the parent table? Definitely the department table is the parent table. Very easy analogy. In the college, how can one employee join if the department is not present? So first concept is the department has to be present in the college. Then only the employee will apply in that department. So if you keep this logical point in your mind, you will be very clearly understanding that department Dept table has to be the parent table, right? So it has to be at firstly created, right? With the department existing in the college. So 3 departments we are seeing 10, 20, 30, pay, tax and art. Then employees have joined there. So it is very natural the department which are existing, employees can appeal on those departments only. So see, from the employee table, E1 is the employee ID, red. He has joined department 10, and definitely this 10 has to be in the department table. E3, brown, he has joined in 30, and definitely this 30 department number department has to be in the department table. Now you will ask me, ma'am, what about this E2? There is nothing written here. Basically, what is inside? We know that this is having null value. That means when this employee, it can be understood by this fashion that employee E2, when he has joined, but at that point of time his department number is not fixed. It may be that he can be absorbed in one or two suitable department. So at that point of time it is unknown. So we can place a null there. That is acceptable. But definitely we all understand that you cannot write here some department number which is not present here. So I think it is now clear, should be clear, that it states that one relation that refers, that means who is referring? The employee table refers the department table, and when it tries to refer, definitely it should refer the existing tuples. That is what mentioned by this referential integrity constraint. You see, very clearly it is written, it is referenced relation and this is referencing relation, right? I think this part is okay for all. More we will discuss. Let us go for the next part. Again we are revisiting and we are seeing that operations obeying this constraint. What are the operations we can do by obeying this constraint? So operations we know, insert, update, delete. So first we are paying attention to the insert operation. At first we are talking about this third point. Insertion of department record will have no restriction, right? It's very easy to understand. Introduction of a department in a college, if it is feasible, it will be introduced. So entry inside the department table of a valid department is not an issue. No restrictions will be there. Now let us focus the insertion operation in employee table. Now you see, either new employee can have null values as department. As you can see here, nothing is written means it is basically having the null value. That means, as I have said, null value for this case, we can imply that at that point of time department ID is not settled or unknown, but employee has joined. When it will be later decided, the null value will be updated by some values. Which values? Yes, from this domain only, because the employee has to join in the existing department only. So whatever decision will be made, definitely the employee E2 will have to join either D1 or D2 or D3. It's very simple. So what is the case of insertion operation? That either new employee will have null value or new employee must have department number that already exists in department table. I think now it is very clear. So you can see an attempt of this employee record has made, and definitely you very clearly understand that this is not acceptable. Why? Because D4. Where is D4? There is no D4 existing. So simple logic. Where the department is not existing, how the employee can join there? So I think this analogy, if you keep in your mind, the whole thing will be clear to you. Okay? So, next operation what we can do? We are talking about update operation. So, check. Update in DPT ID is possible when there is no employees working in it. What it is saying? Let's see. If we can see, we can check. So this is not basically done. We have done across. So there are 3 tuples here in employee table. So you can see which department number, which department is having no employee. We can clearly see that is D3. So if you want to update the value of department ID D3 by D3, it can be done easily because there is no tuple which is pointing or referencing this existing value. So it is done. So you understand this. And another update for employee side, modifying employee departmental is possible only when such department exists in the department. Same old logic. So I want to change this D1. At any point of time, employee can be shifted from one department to another. It is feasible. So department D1 can be now D2. It is acceptable. Why? Because D2 is referencing to the existing tuple of DPT table. So this is done. So I think all these logic are very clearly understood by the class. Okay. So update done. Delete. Now we are talking about delete, right? Okay. See, delete. I think you very well understand. If I suddenly try to delete one table, it will be a massacre because there are so many employees working in the department. So this kind of activity is not at all recommended. But you can very well understand, if any employee leaves the department, there will be no harm. So keep this analogy in mind and just map in this scenario. You see, an employee can be deleted from the employee table with no issue. Fine? But you see, a department record can be deleted only if no employee is working there. That means, you see, in this case, tell me which department I can easily remove. Definitely D3 I can remove, because if we check this employee table, we can observe that in D3 department, no such employees are working. So there will be no referencing mismatch issue. So it will be easily done. So these are all operations which obeys the referential integrity constraint. Now this is the formal definition, right? It is easy to remember. See, there should be no unmatched foreign key in the database. Now you will say, ma'am, we don't know about the foreign key till now. We haven't used that term. Okay. Comfortably we will understand the concept and then we will map with this line, right? So, as we have discussed earlier, department table is the parent relation and employee table is the child relation. Department ID is the primary key of department table, which is underlined, and EMP ID is the primary key of the employee table, which is underlined. Fine. And I think you all can find out that this DPTNO basically is referencing this, making a reference to DPT ID. As same concept, we are just continuing. Now you see, we have added one new term, foreign key. So we can say the attribute of a table, of a relation, is termed as foreign key if that attribute refers to the primary key of some other relation, or it may refer to the primary key of self. In this case, this is not referencing to the primary key of this its own table, but there are cases in some next classes we will see that there are some cases where foreign key will refer to its own primary key. It's possible. In this case, it is only one reference is done, that this key, the attribute which refers to the primary key of another table, in this case, so department number in employee table is the foreign key, which refers DPT ID, which is the primary key of department table. So this is basically the foreign key concept. Okay. Now, if it is so, if you understood the DPT-NO for employee table is foreign key, which refers to the primary key of department table. Fine. Now you come, so now your primary key, foreign key concepts are clear. So let us now revisit this line. What it is told? There should be no unmatched foreign key. Yeah, you see, 10, it is having a match. 30, it is having a match. Now people, you should be able to understand that here basically null is there. So null is acceptable. Null means at that point of time it is not known. Later when we will know it, we will replace by some value. But what value? Definitely the value which is present here only. So it can maximum have 10, 20 or 30. I have explained the logic. So from here another point you should be able to frame that foreign key will not have unique values, because you can understand one employee, there can be many employees working in department 10, maybe that E2 is working in department 10, it is feasible. So foreign key will may not have unique values. Moreover, it may have null value. As you say, as you have seen that initially it was not having anything, that means nothing means null. That means initially we don't know, we have not settled what will be his department, so we made it null. Then when the settlement has been done, null was updated and some values are put. It may be that he is posted in 10 only, it may be. So that is also a point you have to note it down. So I think you are getting this line, meaning that there should be no unmatched foreign key in the database. It's the formal definition of referential integrity constraint. A very small definition it is, and with the example you will be able to remember too, right? Now you see, by virtue of this referential integrity, basically we are establishing a parent-child relationship, right? Parent is department table and child is employee table. Why we are saying? We have discussed. Department should have its footprint first, then the employee can join the department, right? The application of referential integrity. As we are saying that parent-child relationship, definitely the cardinality is 1:n. So if we draw the ER diagram, so we will say department is having a relationship with the another entity, that is employee. Wait a second. Yes, employee. I am writing in short Dept. So here we will write the, say it is employees. So department, employees, employee. Fine. So what is the cardinality? Let us check. One department can have how many employees? Many employees. So n EMPs, right? Now one employee can work in how many departments? Definitely only one department, right? So if you check the cardinality, check this side. Department side is 1 and employee side is n. So we put 1 here and n here. So it is an 1:n relationship between these two entities, and definitely they are having parent-child relationship. And this has been possible by the virtue of referential integrity constraint, which is the fundamental theme of the logical linking between the relations, different tables in relational data management system, right? Okay, so this is the thing I have explained, right? Okay. Now, how to implement this? How you decide that, how you build this logical linking? What is the code for that? So as you understood that parent table will be created first. Parent table is department table. So create table Dept, and you are allowing all these attributes, data type, data size and the constraint. We have all discussed about this constraint. Definitely Dept will be primary key. Dname, we have put it not null. That means at the time of creation of the department table, we have to give the valid, a good department name. So we are saying that it should not be, null value we will not allow. It should be not null, right? Dloc is a varchar, means variable characters, as you know, 20 of 20 size. It says where are the locations of the department. So basic parent table has been created after this. DDL command, data definition language of SQL. Next we will create a child table. So we are creating EMP. As you know, it is EMP ID is the number, data type 3 size, and it is the primary key. Ename also we have settled it. It should not allow null value. So at the point of insertion, value should be given. Salary component. Now com is for commission. We are allowing null values here. Means if the employee is not applicable of getting any commission, in that place it will be 0. Because as we have seen that com 0 and com null is different. Com 0 means he has not received any commission. 0, it's having a numeric value 0, it's a value, valid value. But null means for that employee it is not applicable. We have explained this. So please carefully remember all these points. Next is age. I have discussed with the check constraints. Fine. Most important thing is that here DPTNO, as we have discussed, that is the primary, that is a foreign key. So how it refers? It is done by this line. References. Who would reference? DPT ID. What is DPT ID? This is DPT ID. Which department? Which relation? DPT relation. Now let it be off for now. Just you understand, if you don't give this also, then also the parent-child relationship will be created. So this is the way of creating the logical link between the parent table and child table by this references clause. Okay. Now we will come to this on delete cascade. Just remember, we have given on delete cascade. In the next slide we will explain it. So this is how we implement the parent-child relationship. That means we are implementing the referential integrity constraint. Okay. Now implementation we have created. We have given the values. Now when we try to do some operations, which operations we will lead to violation? Let us check. Say update. If we want to update the parent record, which is the parent record? Department is the parent record. So we can update when? Now when there is no child existing. That means we have said it before also. Department 10. There is one child 10. There is a reference. So I cannot suddenly make it 100. I cannot. So that is written where if you try to do that, they will say this error, child record found. So you are restricted to do that. So when it is possible, when there is no such, that means we can change this. We can change this one. We can do it to 100 easily. But updating the child record, when it is possible, you can do whatever you can do in this department ID section. Whatever values you want to mention, all the values has to be present in this case. 10, 20, 30. That is what it is written. Update the child record is only possible if parent record is present. Right. Now, to avoid the error situation, what is the error situation? The child record found. That means we want to do this thing. We want to change this 10 to 100. As you know that it is a violating, so child record found will be given. But we can avoid that situation. How? We can use this on update cascade, this clause, as we have done on delete cascade. We can apply on update cascade also. Then what is the benefit of it? Whenever you change the value here from 10 to 100, so whatever the tuples who were pointing to this, accordingly they will be also automatically changed. So there will be no mismatch then. The constraint is obeyed. So that is what. So you can do that. That means the update effect cascades from parent to child. That means if the parent record is updated, corresponding child record is also updated. As I said, if you make 10 department ID to 100, at that point of time, who were 10, everyone will be updated by the value 100. Got it? So cascading effect will be seen. Next, if we want to delete, as we have seen, at any point of time employee can be deleted. But if I want to delete the parent record in this case is what? Parent record in this case is department. We cannot at any point of time we cannot delete the parent record, because parent record can have child record existing. So if we will be able to delete any parent record, then what will happen if we delete this? So whom it will refer? So child record will be orphan, isn't it? So then that constraint violates the constraint. So it is not applicable. So the essence is no child can be orphan. We cannot make any child orphan, right? So what we can do? Either child records are deleted, that means let the employee go out of the department, then the department can be shut down, right? Or children are deleted along with their parents. That means same cascading effect. Same cascading effect. That means whenever we try to delete this, automatically the record which was pointing to that will be deleted. That means the deletion is cascaded from parent to child. And how is it possible? How is it possible? By giving this on delete cascade clause, right? So I think all these concepts are clear to you. Fine. Okay, so we are done. Now we are done with the concept. Now we will do the 2 case studies and just revise our concept once. See, the following table has 2 attributes, A, C. A is the primary key, C is the foreign key. So this C is basically referencing A, and there is a on delete cascade applied. Then what is it? That means whenever the parent will be deleted, at the same time its corresponding child will be also getting deleted. That is the on delete cascade we have learned just now. So that is the feature added. Now the question is, if we remove this, if we tuple 2, 4 is deleted. That means this tuple is deleted. We want to delete this tuple. Then, additionally, which other tuples will be getting deleted? See, let me make it clear. A is the PK, primary key, C is the foreign key. Now, 2, 4 is deleted. That means basically the primary key 2 is deleted. So then what will happen? Primary key belongs to the parent table. So what will happen? The rest foreign key which was pointing to this 2 needs to be deleted. Which are they? See, this one and this one, because 2 it is pointing to this. So on delete cascade will remove these 2. Whenever this will removed, please check. Again another case is 5. This primary key is also getting deleted. So foreign key who was pointing to this 5 needs also, it will also be cascaded by the cascading effect will affect that also. So this one will also be deleted. So these 3 tuples will delete if this 2, 4 tuple gets deleted. So the answer will be this one, 5 to 7 to 9, 5, right? Okay. The last for today, there are 2 relation R1, R2. R1 is having the primary key A, R2 is having the primary key D, and here it is written C is the foreign key, say which is referencing to this one, right? Now the question is, suppose there is no violation of referential integrity constraint, corresponding relation instances R1 and R2, small r, small r2, they are the instances, capital R1, capital R2 are the relation. Which one of the following relation algebra expressions would necessarily produce an empty relation? What is the RA here? Minus A minus B. What is the meaning? That the values present in A but not in B. The answer is that after this minus operation. We know this. So now we will try to understand which expression is right. Okay. Here what is said? C. C is the foreign key. We know it. And D is the PK. So basically C minus D it is having, we are doing the projection, that means all the C values, C column values and D column values. So it is said that it is present in C but not in D. Is it possible? Primary key में 10, 20 है, fine. So when the foreign key will be there, it has to be within this only. It cannot have 10, 20, 30. It can have 30, but here 10, 20, 10, 20, 30, except that it cannot be. So present in C but not in D, you will not get any value. So there the answer will be an empty relation, and this is what it is said, it is empty relation. So basically we have targeted with the answer. If you check this, it is wrong, because here it is said, so basically according to the question this is the answer. So we should say about this also, that why this is not the answer, that also we need to make clear. What it is told? It is told D minus C means present in D but not in C. It is possible. As I said, say C. Sorry. C means what? C is the foreign key. C is the foreign key and D is the primary key. Say 10, 20, 30 department IDs are there, and say C में 10 or 20. These two are there. So present in 10, present in D. D minus C means what? Present in D but not in C. What is it? I think everybody understands. Present in D but not in C is 30. It is possible. So it will never lead to, may not lead to the empty relation. But we want, the answer is necessarily produce an empty relation. So definitely this is not the answer. It may not produce empty relation D minus C. But this one, as we have explained, it has to produce the empty relation. Fine. So I think the concept of referential integrity constraint is done. In the next class, we will give many more case studies and we will solve few more problems so that we have a thorough knowledge on this concept. Okay. So for today, the class is ending. Thanks a lot.